Hi guys, so in this video I'm going to tell about crucial data collection mistake that when you know it, you can avoid in your data collection. I will be telling story of my PhD study in which we made some mistakes, and those mistakes actually cost 2 years of time. We had to manually correct data and go through it, and it took 2 years. And it was not only about the time, it was dull work. It didn't feel meaningful work. It felt like wasted time. So I will tell about those mistakes, and I will tell 3 points how you can avoid those mistakes in your data collection. Just as a reminder, if you find value in these videos, maybe click the subscribe button. In my PhD study, we wanted to measure muscle activity during normal daily living, and it's actually surprising, but nobody had done it before properly. So it might be because it's difficult. You have measuring EMG in the lab. It's not very difficult. You just put the devices, but it is a lot of electrodes. It is a lot of cables. There's maybe Bluetooth connection or wireless connection. So doing it in a free living and for a long duration of time with a lot of participants, it is challenging. How we ended up doing is that we were using EMG swords. Those were at the time the new thing. They were at prototype level. So basically you had in swords, you had integrated textile electrodes, and also the cables were integrated and the data locker was integrated. So quite a practical package that you just wear the swords and they are measuring EMG activity of quadriceps and hamstrings. Now they also measure glutes, but at those prototype level swords we didn't have the glutes. As that was a new measurement method for EMG, we went to test it in the lab. We were using data locking in the actual measurements, but those swords had Bluetooth, so we could actually in real time see the signal that they are giving, and we started doing different kind of tests. We went to squat position, stayed there, and we saw nicely that the quadriceps activation went up and stayed up, and then when we relaxed the muscles it went down. We did hamstrings, we did walking, and we could see nicely the muscle activity of each step. And then we also did like MVC test, and we could clearly see that they are measuring pretty well the muscle activity. We did like small activation of quadriceps. You can see the data. We increased the force and it was following nicely. So from these lab experiments everything looked good, that we can actually collect really good quality data from daily living. And then it was time for the daily measurement with actual participants, but right away we started to notice some problems. We had 4 different sizes of swords: small, medium, large and extra large, but it could be that some person was quite in the middle, and the fit of these swords needs to be really good because you don't want to have any movement between skin and the electrode. And then when we started to rotate, maybe the small swords were still in the washing machine. There were some other participant was having them when we had the participant coming in the lab, so we had to do compromises with the size of the swords. We got with some participant we got some movement artifacts that the electrode was moving in relation to the skin, and you can maybe see it in the data that it's not perfect. And also additionally, when you for example sit down, your hands on your thighs, the pressure is changing, so you get some movement artifacts. And also other things, when you sit down, you're sitting over the electrodes, and that might cause some artifacts. So we started to notice that the data we are getting from free living is not as good as from the lab. We knew that the data is going to be quite good but not optimal, and then we had to go on with the measurements. We got the funding for it, and I had a PhD to make, And then when it was time to analyze the data, and we wanted to analyze more things like different bursts from the activity, and usually artifacts were really high and the normal activities were low, so we had to start fixing the data. We had to go through the data, and we were measuring with 25 Hertz, so we had a lot of data points, but we didn't have raw data that we would have, like for example 1000 Hertz. So we tried to develop an algorithm that could automatically fix the data, but it was too difficult, so we actually had to go through the data manually and delete the parts where there was some mistakes in the data. We were measuring 1 to 3 days from each participants, on average 15 to 16 hours per day. So we had on average 2 days from each participants, so we had about 30 hours of EMG data from each participant, and then we had about 130 participants, which equaled 4,000 hours of data. And we were measuring with 25 Hertz, and we had 4 channels, so we had 100 samples per second and 4,000 hours of data. And when you calculate 4,000 hours, how many seconds it is about 14 million seconds, and then we have 100 data points from each second. We end up with 1.4 billion data points. So it's quite a lot of data, and of course computers can handle a lot of data, but we had to be able to go through it manually and have a software that was able to visualize it for us, and then that we were able to easily delete certain parts from there. So we had to have software that can do it. So if you think that during 1 cup of coffee we could go 10,000 data points, it would equal 144,000 cups of coffee. So quite a bit of work. In the end, it took us about 2 years to actually go through the data manually, and after 2 years we had the data that we can start to analyze. So it was clearly like 2-year delay for my PhD for the study. We were able to do it, but it was a long delay and quite a bit of dull work. But actually these experiences and obstacles actually provided us an inspiration, a mission when we established our company FIBION. We really wanted to make the workflow super easy. So whether it's a researcher or a professional consulting people from sitting and activity behaviors, we wanted it to be easy. I think many of the research devices are not designed from the perspective of the user. They are not easy to use, so we really wanted to change that. We started to develop the workflow of the use. So when you start the measurement, what you need to do is just click start. You need to do nothing else. You don't need to fill background information of the participant. You don't need to select different settings. You just click start. So very simple. Then when you give the device to participant, what do the participant needs to do? Nothing. Just wear the device. And then when the participant have worn the device for the duration that's determined, what do you need to do to transfer the data from the device? You either just plug it in and it works, or it's already automatically with our FIBION Sense device. It's actually automatically sending it, so you don't even need to get the device back or even plug it in. And especially you don't need to play with Bluetooth connection or different softwares. Then about the data analysis. So we already analyzed the data in the device. It's also recording the raw data, but you get already results in the device. So if you want to get the fast results which are scientifically validated, they are already analyzed in the device, so you don't need to transfer the big data files and then start churning the numbers. If you're measuring a lot of participants, even the amount of data that you need to put as a backups to different hard drives, that's already quite a bit of work. So we wanted to make it as easy as possible. An additional thing, which is usually really a problem in research projects, is to provide participant feedback. Participants in many places, they are doing it for free, and they are expecting that they get valuable information, for example, of their activity and sitting behaviors in this case. But then when the data is analyzed, it's not done yet, because you need to provide something for the participants. Probably you have promised participants with feedback from the measurements, like results, and with many softwares it's maybe quite many clicks, or for example in our case with EMG, we had to do those reports in Excel, and it was a lot of work. How do you then get the reports to participants? And this many times, even though it's not extra work, it might feel like, because it's not getting your publication, your research, your PhD forward. So how we have done it in FIBION, that those reports are automatically created. So you get the 5-page PDF report, which actually explains in plain English what those results mean. So you can just send the PDF to participants, and you don't need to explain, you don't need to write long emails explaining how to read the results, but everything is included in the report. Or the other way is that we create an online report when you can send just the link and people can access with their smartphone, with any web browser in their computer. So all the way from starting the measurement to participant feedback analyzing, we have tried to make the workflow as easy as possible. We can provide scientific accuracy, validated data, but much easier than many other devices. In case of academics, there is a lot of work. You have the teaching load, you need to do research, so many people are overworking, they get tired. So we really hope that we can at least take small part away from there in the data collection and analysis, and make it easier for researchers. So what 3 points we could learn from my PhD experiences? Number 1, analyze your data all the way to the final results before starting full-scale data collection. And this might sound like a no-brainer, but it's actually much easier said than done, because you are pushed by time, you might not have the software, people might not know how to analyze the data, and you start to recruit the participants, and there's so many things to do. You are measuring a lot of data. In our case, we were measuring EMG, we were measuring heart rate, acceleration, MVC, different daily tasks. So it was a lot of data, and it's really easy to say that analyze the data before, check that you can analyze it, check that everything is alright, but it's easier said than done. So schedule time for it, that you actually really have time to do it. Do pilot measurements and then analyze, and even draw graphs from the data like you do in the scientific articles, because many times you notice there that we didn't measure MVC, so we cannot actually put the relative muscle activation, or we didn't actually measure the EMG of sitting because we were so focused on different activity levels, or maybe your focus was different. Second point, steer away as much as you can from prototype level devices, systems. And also, this is a no-brainer, but it might be easier said than done, because in research we want to advance knowledge, and the prototype level devices provide new information that we were not able to measure previously. But if you can, don't use prototype level devices, maybe use them when they have been tested, and also steer away from devices that hasn't been validated yet, because you will have problems when you start publishing. And many research projects start with that. You start measuring and then you notice that we need to validate this first, and it might take time, and it's a bottleneck because you need to get the validation paper published before you can get the other papers accepted. And as we know, scientific publications can get delayed a lot, so you really want to have devices that are measuring data that has been scientifically validated earlier on already. And then as a third point, again, kind of a no-brainer but easier said than done, match ambition to resources. Don't try to collect too much data, don't try to do too big things. Consider what kind of resources you have. Consider that you will probably have 10 times more problems than what you expect, and then calculate that what is it possible to do in the time frame of the project, and also the time that you have actually time to write the articles and do the reviewing process and all that. So don't shoot yourself in the foot. Match the ambition to resources. And if it's a case of a PhD is just a degree. It's about learning to be a scientist, learning the scientific methods. So don't be too ambitious with your PhD project, because that way you are just asking for troubles for yourself. Glad to hear your comments on this video, and glad to hear in the comments what kind of problems you have had in the data collection and what would be your advice how people can avoid them. So if you're interested to see the results of my PhD study, I will add a link there where I explain what kind of results we actually found, what is the daily muscle activity, how many bursts you have per day, what is the average level, what does this has to do with our type 2B muscle fibers. So check out that video, and really glad to hear your feedback and improvement suggestions of this video, and also leave in the comments what kind of problems you have faced in your data collection, and if you have a solution how people, other researchers can avoid those problems. Put it in the comments. And if you find value in this video, click the red subscribe button and maybe thumbs up for this video. It will help me a lot. So thanks for watching and have a great day.